This is the question, this is the value they gave, 1 over S, 1 over S, S is the substrate, V, absence of inhibitor, and then presence of inhibitor. These are the values. Now the number B, the first one is ask us to plot a graph. And then plotting a graph, we have to understand this equation, which is Lineweaver-Burk equation. We derive it from Michaelis-Menten. I've already solved this thing, so I'm trying to explain it. We have V0 here equals to V max concentration C over Km plus, concentration S. That's Michaelis-Menten. And if we want to get Lineweaver-Burk equation, we'll invert this particular Michaelis-Menten equation. Inverting it, the same Lineweaver-Burk equation is the same thing as double reciprocal plot, right? So 1 over V0 equals Km plus, like we've inverted the whole thing, and then we modify this equation. We're having 1 over V0 is equal to Km over V max plus, S over V max concentration S. We cancel S, and then at the end of the day, we have 1 over V0 equals Km V max concentration S plus 1 over V max. We now get the equation of a straight line, which is y equals mx plus c. So if you are going to plot a graph, our y-axis will be 1 over V0. Our x-axis will be 1 over S. Do you understand? Our m, which is the slope, will be Km over V max. Our c, which is the intercept, will be 1 over V max. Now this is what we are talking about here. Look at it. So if I'm plotting a graph, I'm going to plot a graph of 1 over V0. I'm talking about when I'm doing like Lineweaver-Burk plot. I'm going to plot a graph of 1 over V0 against 1 over concentration S. And then my slope from this equation of a straight line is Km over V max. Do you understand? And then the intercept, which is my C, is 1 over V max. Do you understand? So where this line crosses across the x-axis, we term it as minus 1 over Km. Do you understand? Minus 1 over Km. And that's where we usually find our, Michaelis-Menten constant, which is the Km usually. So this is how we're going to plot the graph. So if we're going to plot this graph now, we're going to plot a graph of 1 over V0 against 1 over S, which is what they ask us. They say plot a graph using this distribution. So we are going to do something like this. We are going to plot a graph 1 over V0 for inhibitor, absence of inhibitor, and presence of inhibitor. Do you understand? So this is how it comes out. I have plotted a graph. Do you understand? This is what I did. I want you to understand it. In a nutshell, this is the y-axis, is 1 over V0. The x-axis is 1 over concentration S. They have done for absence of inhibitor and presence of inhibitor. At the end of the day, you saw the intercept. This is for absence of inhibitor. This is what it is here. Look at for absence of inhibitor. This is my minus 1 over Km. This is absence of inhibitor. Do you understand? And the presence of inhibitor is the one at the top. Look at it here. So from here, I can get my 1 over V max. I can get my minus 1 over Km, because in that question, they ask us to find the V max and Km, and both in the presence and in the absence of inhibitor. So this is what I did. I followed from this particular graph that I drew here, and then I had to, get my V max and then my Km, and then I replicated it here. Do you understand? So if we come here for absence of inhibitor, my V max, my minus 1 over Km is something around 0.04. Do you understand? I want you to just follow through this step. You do your, I don't want you to follow what I like. Don't use my, the same thing I did exactly, but I just want you to follow this step, understand it, and work on your own and give me your answer. Let me see what you've done. So this is the same thing, but this is very correct. Are we together? So this is my Vmax and Km in the absence and in the presence of an inhibitor. Now they ask us to find the slope. Now remember that slope, as I told you earlier, from here, we said our slope is what? Km over Vmax. And they ask us to find the slope during the absence of inhibitor, not in the presence. So if we want to find the slope, now look at what we're going to do. Usually slope is y2 minus y1 over x2 minus x1. But here we're not going to use y2 minus y1. We're just going to use Km over Vmax because it's simpler. You can also do y2 minus y1 and then you get your answer. Already I've formed a triangle here. Look at it here. Look at that slope. I've formed an angle here. So I just wanted it to be shorter. So we did Km over Vmax, which is 10 over 25. 0.4 is my slope. Now, number D, they ask us what type of inhibition is that. Now, remember, we have 3 types of inhibition. We have what we call, competitive inhibition. We have non-competitive, and then we have uncompetitive. Now, in the competitive inhibition, both the the two slopes where the presence and then the absence of inhibitor, they usually join at the middle, like at the line that crosses in the y-axis. That's where they usually join. There is a point here. There is a joining at the middle. That's for competitive. Now for uncompetitive, in uncompetitive, there is no joining. Do you understand? They go separately. The two lines, like what we did here. If you look at what we did here, look at what we did here. There was a different direction. This one for without inhibitor, and this one was with inhibitor. They cross the y-axis separately. No one there is no joining here. Do you understand? And that is what for uncompetitive what inhibitor. And then for non-competitive inhibitor, it's more like a broom. It's like a broom where there is a head. So there is a particular point which is here. They join together. Both this line with inhibitor and the one without, they join at a particular point. I don't know if you're getting what I'm saying. So that is it. So from here, you already know the type of inhibition this is. So that is it. That's just it. I don't know if you get what I mean. So you can use this idea to solve for the other one. I hope this helps. Well done.